Hope everybody's staying safe here. We're almost up on a year with this thing, COVID-19. I just have a couple of things for you here from the shop. First, I just want to give final comments on that precision protractor from Banggood. I know 2 people have picked one up and I'm thrilled with it. So, and then next or last is Rivitnuts. I stumbled across them and know what they are. I'm not sure if everybody else does, but the tools to put them in are rather expensive. So I had the brilliant idea of making my own tool to insert and squish them and whatnot. So hope you enjoy and see you next time. Thought I'd come back and just give a final on this guy and what I did to it. I couldn't be happier with this thing, protractor as it is, after I finished doing all the mods. This L piece here, put it in the tool grinder, cleaned this edge up, cleaned that face up, because I just like it nice and clean. I mean, it was kind of raw. Like I said, this face here to this face is perfect. Didn't really have to do anything to it. I just did a quick light lap on it to get it smooth. But this face to this face is not square. There's a high spot here and a high spot here on this one. Like I said, in the mill I could get rid of this high spot and this is perfect. Not sure how to do this yet. You can see where they tried to file it down, but okay. So I'm just gonna live with that. This guy, yeah, did some lapping and cleaning this thing up and did this face too in the tool grinder. Made this better knob because of this thing being in the way. Now it turns easily. Still need to get the 2.5 millimeter set screw for this knob to replace this. That'll make that nice. And if you look down here, you should be able to see a brass piece in there. They had these guys in it, which sat this way with springs behind it, and some 2.5 millimeter screws go down in there and screw into the end here, where you can probably see one of them there, and there's the other one. It was difficult trying to slide these things with these in place. So I made a brass one for here and for here, and it just slides ever so easily now. It's just beautiful. I mean, both of them perfect, like glass, professional. As far as this scale being off, that was 2.5 millimeter junky screws they had in there. I drilled it out, retapped it to 3 millimeters. I had these screws sitting around, shifted it, and it is now absolutely spot on, beautiful. I checked it with a 90 degree, a 45, and a 60 degree, every time spot on. I was able then to put this guy in here and accurately measure what it was. This is 84.5 degrees exactly. So, conclusion, this is well worth it for me. I'm going to love using this thing. I have to keep, unfortunately, this knob off for it to sit down in this box. Otherwise, it's just too tall. This has to come off too, and I'll just put it in here. It's got a spring under it, so this wasn't that difficult to make. If I can get it off, there. See, it's a little inset, and there's the spring. So I can put the spring there and the knob there and close the box. It was well worth it for me. So, surfing around Amazon as usual, I stumbled across this guy, Rivitnuts. I've seen them before. Used them. I haven't used them, but I've seen them in products and things like that. This is the whole metric set. I think it was $16 or so. M3, 4, 5, 6, 8, 10, and 12. These things are massive. But since the tool is expensive, figured I think I can make a tool that will do this. These are steel. Aluminum's probably easier, but I think it was, I don't know, I can't remember now. I couldn't find any aluminum ones, but I know I found them now. So I'll take you over to the lathe and let's start making it. Alright, I'm not going to show a whole lot of machining on this. Only that which I think might be educational. So this is the large part of the shaft here that the nut rides on. This is the second one. The first one, I'm not sure if the camera can see that. Yeah, it is. On a mini lathe, when you try to do really heavy duty threading with a threading die, it just does not work. I mean, the machine cannot take it. Material starts slipping in the chuck, tailstock. You have the threading die in the tailstock trying to keep it straight. Tailstock pivots, tilts, you can't do it. So first one, yeah, I was hoping for luck and didn't get it. I just tried doing it in a vise and hoping I could get the threading die to go on straight, but that just didn't happen. So it's crooked. So second one, this time I'm going to move this to the other lathe and do threading on the lathe. So I already turned this down. I've just got a little bit more to go. And before everybody bangs on me leaving comments, why am I going from left to right or over here to here? Very easy. It's a mini lathe. It's not very solid. This is 1018. This is the ugliest material, in my opinion, on a mini lathe to turn and get a nice finish. This is the only way I get a nice finish. If I go from right to left, it's god awful. So, and it also seems to be nicer when I just really douse it with my special cutting oil or whatever, kerosene and motor oil. So I only have like 14 thousandths to go, but I'm taking 10 thousandths cuts here. So I'm gonna go in 5, and I'm on the lowest gear setting. It's doing its own power feed with the lead screw. And you can see the finish when you run your hand on it. It's pretty nice. Really easy to clean up with sandpaper, Scotch-Brite. So, and I love this insert. And just this Cobra carbide, tungsten carbide insert. Chip rigger didn't work too hot, but fine. Yeah, paper towel and kind of clean this up maybe. You can see it when I'm done. And then I'll turn the camera off because I want to do my final pass here. Just focusing on it, paying attention. Almost done. So yeah, again, 1018, terrible stuff. This seems like the nicest finish with this insert. Let's see if I can clean that off a bit. Oh, that looks terrible. Trust me, it's not that bad, but yeah. So that can be cleaned. Oh yeah, it's a little fine particles in there. But yeah, where am I at anyway? Get the, I need to go to 70. So what have I got left? I'm at 77. So I have 7 thousandths to go. 70, yeah, 77. Double check that with this thing here. Yeah, 70. Alright, so I just got 7 thousandths to go. Maybe I'll show one more little cut on it. If I took 3 thousandths, yeesh. Yeah, might as well just do it, huh? On camera. What the heck? Alright, so I want to do 3.5 thou. Alright, so there's 1, 2, 2.5 thou, right? Yeah. I really think about that. 2.5 gives me 4, 5. That gives me 5 thou, yeah. Alright. And it seems to be nicer too if I really keep this thing soaking with oil, cutting fluid. Yeah, I should have done 3.5, 2.5, so and another thou to go. Light cuts, I don't get a good finish. See, this is why I like doing it off camera. I don't get distracted by what's going on. Be curious to see what the finish is going to look like here on with a 1000 cut. Alright, do I want to try it? Let me measure it just for the heck of it. Alright, where am I? Whoa, I'm right on it, 370. Yeah, that's interesting. That shouldn't have happened, but it did. So, I'm done here, huh? Clean it up a little bit. I'll get the oil off of it. Disengage the power feed. There. A lot of oil on that, huh? Alright, let me get, what have I got, 600 grit. Take it up. Wrong way to do that, Dave. Gotta get this magnet out of here. By the way, the splash guard works beautifully. I mean, almost nothing, literally nothing, hit the floor. So yeah, I was thrilled with that. Well, it gets cleaned up, huh? This is going to get threaded, so I really don't care about the finish that much. Scotch-Brite. That's not too bad, you know? Not too bad. I don't know what the camera can see, but like I said, I don't care. Otherwise, I'd be just sanding this a whole bunch more. Alright, so it's time to move this guy over to the other lathe. Not sure how good the lighting is, but I'm just going to show one pass of this so I can concentrate on what I'm doing. Normally, well, I didn't have the threading dial mounted on the machine. And normally I just make one pass and I'll stop, put it in reverse, and back it out, never disengaging the saddle. But there's too much play in the half nut, so it's making a mess. So now I put the threading dial, whatever, on the saddle, side of the saddle. It's engaged with the lead screw, and so I'm using it, trusting it to do the job. Have my relief in there. Probably should have made it a little bit wider, but so in low gear, it's doing a nice job. So yeah, I probably need more oil on this thing. Try to clean off some of this garbage, huh? Oh well. Alright, so here we go. One pass, huh? It's coming up, and oh, I missed it. Gotta wait again for the dial to come around. Oh, I never went in a couple of thou. So like I said, I need to just pay attention because I don't want to mess this thing up. There, it's engaged. So it should make one pass here. Right on it too. Beautiful. So kind of like threading. It's fun, and this sucker is sharp, boy. It's just doing a nice job so far of dealing with 1018. Let's see how far it goes in now. And I just hit the power switch to kill it here. There. So that's it. I'll probably bring you back when I'm way in there. Well, that didn't go exactly as planned here. Kind kind of a small discovery. The point on this guy isn't far enough to go deep enough to finish this thing here. It winds up bottoming out on this, and no, there's no lip on this side, but the triangle part isn't big enough. And then I realized, wait a minute, I had this guy a long time ago that I had made. That would have done the job just fine, but luckily I could get a threading die on here to finish this off, because there's no way the nut was going to go on there. So now I had a choice. I could either put this in the mill and put a flat here for a crescent wrench or wrench to keep it from turning when I'm doing this, to draw it in to flatten this guy out, or I can permanently Loctite a nut on here and have another nut on it. Well, I can run the nut on from this side, but so I'm not sure what I'm going to do with that yet. But in any case, now I need to turn this, you know, cut it off, probably longer than I really need, right? Because all I need is this length here. So how am I going to mark it? If I'm going to have it sit there or something like that, I just mark it way down here, saw it off there. Turn that down to this and thread it. This being small enough and thin threads, I can just use a threading die. I don't have to go through this stuff again, because that's pretty time consuming. So the idea is turn this all down, and it's just a threaded part here. So what I wind up with is the larger part here. Hello, there. Larger part that's threaded, and it comes down to a teeny little part that's threaded. And then I gotta make my cup, collar, or whatever you want to call it, do this. So this face right here sits on top of it. So it screws in, sits on it. This will be a lot longer here. And then the nut goes here and it draws it up, right? Yeah, I'm going to turn the nut, it's going to draw it up and squish this thing, I hope. So now this to make, and then the pressure, I don't know what you want to call it, pressure part. I think, yeah, this is a 4mm. Is it really tight in there or what? Yeah, that's pretty sloppy. I might wind up doing this after all, because I want a very good tight fit in here. I don't want to be stripping the threads out in this thing. So onward and upward, I guess. Sorry, I didn't film doing this thread here. Critical part, so I just wanted to pay attention. 4mm 0.7 pitch. I figured I'll do it on the lathe here, you know, the threading with the dial, the gauge and stuff. But for some reason, it was not working. I set everything up, changed the gears. Oh, I had gone on the internet, since it's metric, and typed in metric gears, and LMS showed a gear set for an Imperial lead screw, what to do. The error was so minimal, it's like 0.006 of a millimeter, so I figured, so what? Made first pass, checked it, it was on the money. Second pass, I don't know, it was off. It just, every time the dial would come around, my black dot, I'd say go, and it just kept going in different spots every time. I wanted to do it on the lathe because I wanted this to be a really nice, tight fit, but it's pretty, not pretty loose, it's pretty good. Should hold, I hope. So I wound up just doing it with the threading die, ran it on there, did the relief and stuff. So now it's a matter of just making this outside piece. Oh, I did cut this a lot shorter, and now hindsight realizing I need a pretty thick wall here to hang on. So if this went all the way through, how much do we have left? Wow, not much. Well, no, that's a pretty thick wall. And I'm just going to do it out of aluminum for now. Piece of scrap. So I'm not going to probably show this. Next up, you'll see me actually using it. But so this is just a matter of capturing this in the forge jaw, clean that up, drill out the little hole here, and then use an end mill to get a flat bottom, bore it to the exact size, cut it off, and I'm done. So, all right, moment of truth here. Not too proud of the way this came out, but I can easily bang another one out. Dimensions worked, it's all the way through, so let's see how it works, huh? That goes in there, there, it's on there. Decided to double nut it, just for the heck of it. This one too big? No. How do you hold all of this at the same time, huh? Is that because, yeah, that's, I guess you push with that, somehow hold this, and see what happens, huh? All right. It's loose too far, there. Is it going to work? Can't get on it. There. Starting to push. What's it doing? I have a feeling when you get a little bit, you don't have to, yeah, it's starting to work. It's expanded it in there. But how far do I have to go? Wow, that's real easy. Oh, it must be spinning. Yeah, is the nut spinning? Yep. So it's still got to be here. Tighten that up all the way so it doesn't fall off. Oh, I can do this in the vise. It'd be a lot easier to hold this nut than doing it this way. Is it flattening it? I can't tell. What happened? Something moved, huh? Oh, my double nut came loose. I don't see it doing anything yet. So I'm gonna do it in the vise. Not sure if this is really gonna work. Double nut keeps coming loose no matter how tight I get it. Okay, I gotta go this way, right? Yeah, to tighten it. Well, so far, I don't see anything happening. Oh, now I see it's starting to bow now. Yeah, it's starting to do it. Can't hold it. There it goes. Yeah, it's working. Somewhat, huh? Eesh. Oh, that was nice. Broke it right off, huh? Alright, I'm not sure how. I think it successfully did it, though, before it broke it. Shoot, that was a lot of work to make that thing. So if you buy one, I have no clue how theirs is going to work that well. Oh, because there's, well, no, I'm pulling on it too. Oh, because I'm turning, I'm twisting, whereas the tool you buy is pulling. But I managed to get it in there, and it's solid. So this technique probably works for the bigger ones, maybe. Shoot, wow, broke it right off. Okay, well, so much for that little experiment. Not sure where I'm going to go from here. I could order the aluminum ones. These are steel, so yeah, that's going to be tough. Well, hope you guys enjoyed.